Welcome to qnawire.
For this question, we can use the energy balance equation, which is E dot in equal to E dot out. If we expand it, we have W dot in plus M dot H1 is equal to M dot H2. W dot in is the power inputs. M dot here is the mass flow rate for the heliums. H1 is the initial enthalpy for the helium, and H2 is the final enthalpy for the helium. So in this case, we have W dot in is equal to M dot times H2 minus H1. And when H2 minus H1 also can be expressed as Cp times T2 minus T1. So therefore, we have W dot in is equal to M dot times Cp times T2 minus T1. And we know the mass flow rate, which is M dot here, can be equal to rho 1 A1 V1. Rho 1 is the inlet density of the helium, and A1 is the inlet area, and V1 is the inlet velocity. And we know the rho 1 can be expressed as a P1 over RT1. P1 is the inlet pressure, R is the gas constant for helium gas, and T1 is the inlet temperature, okay, which is the initial temperature. So eventually have W dot in is equal to P1 times A1 times V1 over RT1 times Cp, and then times T2 minus T1. Cp here is the specific heat for the helium gas, okay? So we know the inlet pressure is 110 kilopascal. The area is 0.1 meter square, and the velocity is 9 meter per second. And we know the gas constant for the helium gas is 2.0769 kilojoule per kilogram times Kelvin. We know the inlet temperature is 20 degrees Celsius, which is 293 Kelvin, and the outlet temperature or the final temperature is 200 degrees Celsius, which is 473 Kelvin. And if you take a look at the table of ideal gas specific heat of various common gases, the specific heat for the helium gas is about 5.1926 kilojoule per kilogram times Kelvin. So now let's plug in back to the equation to determine the power inputs. So the power inputs can be equal to 110 kilopascal, and then times 0.1 meter square, and then times 9 meter per second, and then times Cp, which is 5.1926 kilojoule per kilogram times Kelvin, and then times the changing temperature, which is 473 Kelvin minus 293 Kelvin, and then over 2.0769 kilojoule per kilogram times Kelvin, and then times 293 Kelvin. And this will give us the power inputs is about 152 kilowatts.